All right, let's get going. Hi, my name is Ryan Lowe, and welcome back to my series of live coding, I guess. So I am a Alexa technical evangelist. My job is to encourage, inspire, and educate developers to build really cool things with Amazon Alexa. Usually, that's skills. You can see I have some Echo devices behind me that I use for testing. But yeah, so my job is great. I get to work with developers all day long, and part of my job, if I'm going to be educating developers, is making sure that I know what I'm doing and I'm building skills myself. And so, what better way to do that than to do it live, where I'm learning, hopefully other people are learning and getting inspired and getting great ideas for what I'm doing. So welcome on my journey of building an Alexa skill. The skill that I'm actually working on is actually one that I hope to publish and get out into the App Store and that other people can use. And so what I'm doing is what I'm building. The use case here is one where I'm hoping it'll be helpful. So every Tuesday, my coworker and I, Jeff Blankenberg, get on and we stream live and we host Alexa Developer Office Hours. We broadcast it to a number of channels, including Twitch and LinkedIn and Facebook and Twitter and YouTube. But when we're done with the live session, there's a video that gets archived in YouTube. And the idea being that if you are an Alexa developer and you have a question, you can join the live office hours and you can ask your question. But what usually ends up happening is that Jeff and I end up answering the same questions over and over and over again as new developers join the office hours, get interested. People have the same sort of questions over and over again. And so what we'd like to do is be able to have this archive of old videos be easier for new developers to be able to search and get answers. So instead of having to come and either wait till Tuesday morning to ask their question, or instead of having to pour through hours and hours of archive footage, they're just able to get their question directly answered. And the way we're going to do this, the way I'm building this, is actually to use Amazon Alexa. So the end goal of this is, at the end of this, is that you'll be able to go to any Alexa device and say, Alexa, tell me about let's just say Alexa Presentation Language, APL, which is a very common tool to use to create visuals on Alexa devices, or any other kind of question. You'll be able to ask the question, and if your device has a screen like these guys here, these Echo shows behind me, then what we want is to actually zoom to that point in the video where we're talking about that particular question. And play the video. And if you have a device that doesn't have a screen, then we would just pull off the audio and link you directly to the audio so you can still hear the answer. So that's the end goal where we're going to. But there's a lot of infrastructure that needs to be built. And so I've been working on this for the last couple of weeks, building this out. But I've been building out the back-end infrastructure. I haven't even gotten to any Alexa stuff yet. Everything I've been building has been just generic. And what I'm working on is a trigger that will go and pull down new YouTube videos as they're posted and store them in Amazon S3. And then what we're going to do is, the end result is to put this into a database that we can search. And I'm building this live. I have a public GitHub repo that I have published, where I'm publishing all my source code in at the end of each of these episodes. And if you go to my GitHub page, you'll be able to find it pretty easily. I have this pinned as one of my pinned repositories. And I have an architecture diagram that is like an in progress. So this whole idea, a few months ago, I put together with kind of duct tape and very hastily put together a proof of concept to see if this idea was even possible. To make sure that I didn't go down this route and waste my time and other people's time, to make sure that if I built a full solution that it would actually work. So I have a little bit in my head of what needs to be done, but I don't have the full details out. And so instead of sitting down and planning for a couple of weeks, what I'm doing is I'm just running full steam and just going with it. And so that's what this architecture diagram shows. There's a lot of empty spaces here. and there's a lot of question marks and missing things. But we're going to fill that out as we go. And actually today I think we can add in a bunch more information. So what have I been working on so far? So far I have built the ability to take a YouTube video. I haven't built the trigger yet. I think we're going to get to the trigger today, where we'll have YouTube notify us when a new video is available so we can go download it. But what I have done is, like, if the video is already loaded in S3, then I've built this whole process, this orchestration that will take the video, and first it runs it through a service called Media Convert. And so the YouTube video that we get is in one particular MP4 format, and the AWS services that we're going to use require a different video format. I don't understand all the details, but all I know is that Media Convert is a service that allows us to go from one video format to another, among a bunch of other stuff. So we converted it into Media Convert, and that's what we've been working on the last few days. And then we run it through Amazon Transcribe. So Amazon Transcribe is going to take this full video and pull out all the text. So it's going to listen to the audio and figure out all the text and give us a transcript. The next step is we run that transcript through Amazon Comprehend to give this a little bit more structure. So we're going to combine into paragraphs, we're going to pull out tags, we're going to pull out key information, and so on. And then now we have a transcript that we can go store in a search database somewhere. And this part I haven't gotten to yet either. We're going to put this into Amazon OpenSearch. Here it's Elasticsearch. The tool I use doesn't have the new service yet. And we'll probably get to this at some point next week, actually storing this in a full text search database, and then we can start actually querying. So we'll query this manually just to be able to test it out. We'll start pumping YouTube videos through, and then we'll start building out the front end. So what's left? So last time on Wednesday, I struggled and failed to get a YouTube downloader Lambda function working. So I should also say I'm building all this in serverless technologies inside of AWS. And so I'm using Lambda functions, and I needed a Lambda function that would pull down. So you give it a YouTube video URL, it would pull down the video and save it into S3. I found a library, I found a blog post that described exactly what I was doing. The blog post was about 3 years old. And when I started working with it, I realized that the library that this blog post references has been deprecated. The new library didn't have the exact same API. And when I tried it, it wasn't really working exactly right. So I kind of failed at writing this Lambda function live last time. But since then, I found a new library to download YouTube videos, and it works great. And I quickly just put it together to see if it would work, and it did. My idea was, if this one didn't work, then I would keep trying in my spare time, or like in between meetings and things like that, to figure out a library that does work. But thankfully, I did find one. So now we have a mechanism, and I'll walk through that. I didn't write it live. I apologize, but I will walk through it. It's a really simple Lambda function to pull down the video. And then we'll add that to our state machine. So I'm using AWS Steps Functions, which is a service and a specific tool inside there called State Machines to kind of orchestrate this entire process. And so I'll showcase that and how this works. So we'll get to that in a minute. But first, let me start off by going to my now complete download YouTube function. So I found this library. I wrote, almost all my other code, actually all my other code is written in Python. I did not find a Python downloading library that for YouTube videos that seemed to be doing what I needed to do right off the bat. I found there's a bunch of libraries and helpful tools that help you like just download a file. So you say, here's where I want you to save the file, go download it to that file location. And I found Python libraries to do that. The problem with that is, in a serverless world, that's not the ideal way to do this. So what I want to do is I want to open a stream to the YouTube video and start downloading it. But instead of saving that stream to a file, I want to redirect that stream and output it into Amazon S3. So my Lambda function doesn't have to store the video, hold it in memory, any of that. We can just pass through it from YouTube directly to S3 through the Lambda function. And the big reason for this is is when you're working with Lambda, you are charged by how long the function executes. So here, normally I like my functions to execute in a few milliseconds, like kick off an API and then wait and have another Lambda function to go check on the status. I'll show that in a minute in state machine. But this one, we have to wait for the whole stream to download and go through. The other thing about Lambda is you're charged by how big your Lambda function is. So I could create a Lambda function that could store the entire YouTube video in memory, or I could save it to a temp location in the Lambda function. But both those are kind of not ideal. They're not super efficient. I'd be downloading the whole video and then re-uploading it. So that's not how I want to. That's not how I want to architect in the serverless world. I want to keep it completely stateless. In other words, so I found this library, YTDL core. Let me actually. I probably am logged out of AWS. So first, I need to log back into AWS. Need to log into my password manager. Let me pull this off over here for just a second. I normally do this before I sign on to the stream, but that's all right. Okay, so now we're signed into AWS. But actually what I was going to do is just look up this package. So again, I'm using Node for this particular Lambda function. No big deal. We can mix and match languages quite a bit. So I have a collection of Lambda functions now. And so you can see here, this one, it has some stale dependencies, but it's not completely deprecated. The library I found last time was completely deprecated. And here, this is exactly what I'm looking for. Just by looking at their NPM documentation, here I want to download a YouTube video and I want to pipe it somewhere. But instead of a write stream, I am going to actually pass through this into a S3 write stream. And so that's exactly what I did here. So last time I kind of stubbed out in CloudFormation. So I'm actually using the service application model, which sits on top of CloudFormation, which allows me to define Lambda functions here. So here's my SAM syntax to define a Lambda function. I say, here's my code URI. So this is where the code is located. And the nice thing about SAM is that there's a build phase it goes through. So it'll go into this directory and it'll do a node build using a Docker image. And I'll showcase that when I deploy this. So it'll pull down all the dependencies I need. So I don't need to mess with dependencies, creating a zip file. I just worry about the actual, the index file that has my source code, and then a package file, a package.json file, which defines my requirements, my dependencies. So here I'm passing into this. I want to specify a long timeout. So again, we're going to be downloading the video, so I need a long timeout. My runtime is going to be the latest version of Node that Lambda supports. I'm going to pass in the environment variable of the S3 bucket name that we defined. So I'm building out in CloudFormation. There's an S3 bucket that gets built out. And then I also define what policies it needs. So here we need the ability to write to S3. So I go back to my code. So here I'm getting the bucket name from the environment variable and then enter in my handler. And again, this is how I like to write Lambda functions, less than, as small as I can possibly get. I probably need to do a little bit better job of logging information here. I have a nice logging framework that I use in Python. I put this together quickly and we can work on this. But here's what I'm doing. So first I create a pass-through stream. So I can take, and then what this allows me to do is I say, when I'm downloading the YouTube video, pipe it to my stream pass-through. And then my stream pass-through then gets referenced in my AWS upload. So here I'm saying upload a file, and the body is the stream pass-through. So this allows me to basically pipe the YouTube download into the S3 upload, and doing it in different part sizes. So this is a really, really nice way to handle moving around large large files, which these videos, they're an hour-long session of office hours, so they can be about a gigabyte in size, is kind of been my history with this. The other thing that I'm doing here, and this is actually really cool, so this library that I found, I was playing with it, and there's another API to get video info. And I don't know what I clicked on. So I was like, what exactly is this? It didn't quite describe to me like what this, like here it is. Gets the meta info from the video, includes additional formats and ready to download. So I was like, oh, what is this? This is going to be interesting. So what I did is I ran this and I saved a copy of it. I saved a copy of the raw JSON, and this one API returns 15,000 lines of exploded JSON. And I figured there's a lot of information in here that we actually probably want to keep. So in here, there's a bunch of other, like you can look at all the different streams and different content formats and so on. You can get the player response. You can even get like, one of the things I was looking at, the different storyboards. So here's a JPEG of like a bunch of different, I think it's like 100 different thumbnails of the video. So you can kind of see like throughout the video, like different thumbnails. So the API is amazing. And so what I want to do is I want to pull from this. So far I've only been worrying about like transcribing the text. And so what I need to do is also I need to get the name or the title of the video, right? It'd be helpful to get a description, but what other information would be useful? So here, now I'm not thinking about how do I transcribe or how do I index this, but if I sit down and think, like when I present this video, if I do a search on the Alexa skill and I say, show me a video of APL, I would want Alexa to say, here's a video from office hours, Alexa developer office hours on January 4th, 2022. Maybe I want to provide some more information, like when was this live, when was this uploaded, and so on. So what I'm thinking here is that I should use this API to not only just get the title and description, but other metadata, and maybe we should save this off into DynamoDB, which is a great lookup database, so that later we can, when we're messing around with the Alexa skill, we can go and retrieve the metadata for this and present it back to the user. I'm not sure exactly what data I'm going to want yet, but I think there is something here that we want to dive into. And so here, what I'm doing, I called this API to get the info, and one of the things I'm doing is I'm getting the name. So I want to be able to save. I need a name to be able to save this file in S3. So what I'm doing is I'm taking the title of this value here, which has a bunch of spaces and other information in it, not necessarily friendly as a file name. So what I'm doing is I'm replacing anything that's not lowercase a, or lowercase letters, uppercase letters, or numbers. I'm just replacing it with a dash. I should say I'm replacing one or more of those together, replaced with a dash. So the end result would be a file name that's a little bit more friendly. It would be Alexa dash developer dash office hours. Here, this whole thing would just get replaced with one dash, comma would get replaced. So it's a little bit more friendly of a name. And then I say that's my output key for this. So I'm putting this in Amazon S3 in a folder called unprocessed. And then later I have a folder called processed, which is where Media Convert dumps this file. So now the only thing I need to kick off this entire thing is the YouTube URL. Previously I thought I would need to get the title and other information from the source, but I don't. I can just call this API and get all of that information. So that's what I'm going to do. And I actually ran this function and it worked great. And if I go over to, here, I'm logged out everywhere. Okay, so let me just start closing some windows. Start over. Okay, so let's go over into we should go into CloudFormation. So what I'm using CloudFormation to deploy this entire infrastructure. Using SAM to build on top of CloudFormation. This is the CloudFormation stack. And again, CloudFormation, if you're not familiar with it, allows you to define infrastructure as code. So here I can define all my Lambda functions I can define my S3 buckets. I can define my DynamoDB table, which we'll do. I can define all that in code in a YAML function and then deploy that up to AWS. And what I can do is I can say, deploy only the changes and update this stack. So I can constantly keep in sync what's going on. And then through this, I can get access to all the resources that this stack deployed. So through here, I'm going to access my S3 bucket. Let me just close a bunch of these other windows. And so this is my S3 bucket. So when I ran this Lambda function manually, it saved this file here. No, sorry, the January 4th one. Yeah, I ran this on Wednesday and it downloaded it. And so this, I may not be getting the right, that is way too small of a file. So I'm wondering if I'm not getting the appropriate version of this. Let's actually download this and make sure I'm getting the right version. So when you go and download a video, there's like all kinds of different file formats that you can choose from. Like different resolutions and so I want the best version, the highest resolution version of the video to download. What I'm hoping is it didn't just like truncate out the video and like cut it off. My water bottle just broke. It's not good. I like this water bottle. All right. It's downloading still. I don't necessarily have the fastest internet connection, but I am using Starlink. I just got it a little bit ago, and it's really freaking cool. Okay, so it is the full length, and it seems to be playing just fine. Yep, there's me, and there's Jeff. Cool. Okay, but the resolution's not necessarily great, so I think we need to go back. When I am downloading this video, I'm just saying, where is it? Yeah. Here, I'm just saying download. I'm not specifying any options whatsoever. And so I feel like I should be specifying some options to allow me to get like a high resolution version. And what I mean by this, so if you do get info on this, so this API returns back just a ton of different information. But one of it is formats, and there's just a variety of different formats you can choose from of the same video. So YouTube is storing different versions, like different resolutions and quality. Quality is the word I was looking for earlier. So what I want to do is figure out how to get different quality. So let me go into the GitHub repository of this library, and let's just read through their documentation, because the video quality I downloaded would actually, let's actually tell me, QuickTime tell me what the quality is. I feel like it should. Window. Maybe I should, let me try this. Maybe Finder will tell me. Get info. More informations. Yeah, okay, so it's only 640 by 360. And I know that there's higher resolution versions of this that we can download. Like there's 1080p. So how do we get, using their API, how do we get different quality versions? And here it is, choose formats. Okay, can be used if you like to choose a format for yourself. Throws an error if it doesn't match. Okay, so I think what we want to do is just say, choose formats. Quality 1 through 4. Okay. So I'm trying to find an example of this. Okay. Perfect. So we're already calling get info. So we already have that. We're getting the name and publish date. Again, publish date. I need to figure out where to put these. So I think we'll put these in a DynamoDB table. So we're already getting get info. Okay, so info.formats, quality 134. Quality, what we want. Typical. Will be sorted in the following way using quality highest. I think that's what we just want to do, is just say quality highest. And I think if we go over here, if I do a search for, darn. It should be sorted. There's medium, HD. Yeah, I think can be an I-tag value, let's see, or one of these strings. Okay, so if we just say highest, this should work. Okay, so now we have the format. So now what we do, we have to pass that into I'd imagine that we pass. Okay, attempts to download a video. Options can be the following, in addition to get info option. Oh, okay, I think we can just do this. Let's try this first. And this is a great example of, so here I'm defining the code, I'm writing the code, authoring the code on my local machine. And then I'm using SAM to bundle this up, compile it, deploy it up to AWS, and execute it. But when I'm doing like small iterations like this, like that can be kind of cumbersome and time consuming. It could take like 5 minutes to recompile all the source code and deploy it up there. So sometimes what I'll do is I'll also just try to monkey with stuff on the actual Lambda function in the cloud, and then when I get it the way I want, then update my local machine to match that, and then redeploy to kind of like wipe it clean and make sure everything's looking good. So here, I'm just going to take this code and just paste it on top of this code, and let's just test this out. So I believe I already have a test configure event. I actually don't need to pass in the name. I just need to pass in the YouTube URL. And it's been deployed. So let's test this. This might actually take longer to run now that we're getting a higher resolution version. I'd expect it to take longer to run. Last time I ran this, it actually ran pretty quickly, which was surprising to me. So let's just wait on this to finish. Again, so I'm using Node. Here's I have a promise. I'm returning the promise back to Lambda, but I'm not resolving it until I have the finished upload. And then I pass back. I say, here's a media S3 location, bucket and key. Now this is the input that my next function in the chain of functions needs, which is the media convert. So it needs this as an input. So we'll use state machine to kind of pass this all around. So this is taking, I do have a pretty good timeout on this. I may have to adjust the timeout, we'll find out. And I got an error. Run timeout exceeded. Okay, so which, look at the configuration. So I have a 2.5 minute timeout. Let me also open up CloudWatch so we can look at the logs there. So presumably it's working. It's downloading a larger version. If I come here, I don't think it ever got into S3, so we'll see what S3 has. Yeah, it didn't save it in S3. So here, runtime exit with error, signal killed. it's not a very high memory. I wonder if I should increase the memory. Let me do that. Let's do this to 512. But still, a timeout is 2.5 minutes. What signal? The only thing I could think of that has a timeout would be that library. Let's test this again now that I gave it more memory. And then, what was the error message? Runtime exited, signal killed. Runtime exit error. Oops. Interesting. Issues. It's definitely not my issue. That time it worked. Okay, so it's definitely a memory issue. Okay, now let's go to my S3 bucket. And it should just replace this file, but the file size should increase from 164 megs. It did not. So that apparently is not getting, that's not how you specify. Okay, so let's do this. Let's do console log format. Let me look at this definition again. Event info. Did I just execute this? I feel like I should execute that again so I could see what the console format was. Oh. Wow. Info.formats. That might be more useful. I forgot to actually put the parameter back in there. I could have probably just ended the function instead of downloading the whole thing. Okay, so quality label 360p. That is definitely not the highest version. Okay, so maybe this is working, but it's just not sorting it. Yeah, this is quality medium. Okay, so let's go back to this guy here. So again, this is a saved response I did of the info. And maybe what I want to do is just find this. Like, what's the highest quality here? HD 1080? Is that going to be my highest quality? I think the library is expecting this to be sorted correctly, and it's definitely not. So this, the first one is width is 640 with 1920. So that may be what I want. This one, where's the width? 1920 again. 720, 720, 480p. Okay, so what do I have selected? 10. Let's try this. And then let's just do this. Return, and this is going to totally blow up my function. Oops. But again, I just want to see if it is able to, if that's the right label to pull out the format. See, this is the danger. Now I'm making a bunch of changes to Lambda. I need to make sure that I get back to my original code on my source, on my local machine, the correct changes. And so this can get out of whack pretty easily. No such format found. Must be this then. But since I don't read the documentation all the way, for me to like do this on my local deploy, compile it up, like it just is way too long of a cycle to loop through there. So what's this error message? That's code 410. What did I do wrong? You'll see this thing just be gigantic and huge. I'm just going to log the info response. No such format found. What are the formats then? I thought I could just pull one of iTag. That's what I need to look for. That's what the documentation said. Okay, let's try iTag 137. There we go. Let me get rid of that huge console.log. I said there we go because it didn't fail. Okay, now we have a proper format. So I think if I go back to this, this should get me the proper format. So I'm pasting down here that iTag value. Hopefully that works a little bit better. Okay, so what other information do we want to pull out of that info? So here are the video details. It'd be good to have like the video ID. That way we can use this as a unique key to our DynamoDB table. So I'm going to store the transcript in Elasticsearch because it's a full text search. I would love to use a serverless database for full text searching, but Elasticsearch or open source search is the best that we have right now. So that's what we're going to use. But for things like I want to save the metadata of this video into a database and then retrieve it by the ID, the great use case for DynamoDB. And so that's what we're going to use. So we'll create a DynamoDB table here in just a minute and get all that squared away. I just want to make sure that I get this coded correctly to pull down the right video format. So we want the video ID. We'll take title, description, length, why not? And that might be it for right now. And the nice thing is we can iterate on this. So if later when we're developing a skill, we want more metadata, great. Just go back into this function and start saving more data. The problem is once we start processing videos and we don't have that video, but that's, we'll have to just figure that out. Awesome. Okay, so this finished. Let's go here. My bucket. Please be a bigger size. Yes, that is bigger size. Fantastic. And that's much closer than what I was expecting the value to be. So let's take this line where I'm specifying the quality and put it back into my function here. I'll leave this commented out so I can remember, like this is, just so I remember the URL, the example. So that way, later, if we're running into an issue, I can rerun this and figure that out if like 137 iTag doesn't exist for all of them. But if I go back to this, the documentation, 137 should always map to like 1080p. And this is exactly, this is what we're looking for. Like, so this should be good. Excuse me. Okay, so now what other information do we want? We want, I'm gonna give these constant values. I said the video ID, right? So equals info.video details dot. So this is video details, video ID. I think this might be good for right now. Oh, let's get the description and length seconds. Okay, we'll just get a couple more. Info video details dot description, and then description. Okay, and then length seconds. And all those should just be under, yeah, video details. There's a bunch more information here. And we'll just not worry about that for right now. So the other thing is this, so what I'm doing is I'm going to end up setting a trigger on the YouTube channel. This channel is going to have other videos like this. It's the Alexa developers channel is what we're going after. And so there's a bunch of other videos on this, but we want to sort out the office hours videos specifically for this. Or actually what I'm going to do is I'm not going to sort them out. I'm going to start indexing all the videos that we put up there. So there's like Alexa Tech Talks and others. But when we write the skill, we'll use the skill to filter out and say we only want videos for and specify the type there. So we'll have like a parameter or Elasticsearch attribute to look for, which would be the name. We could say like office hours. So we'll add that in there, and then we'll also start indexing other videos too, and see what happens. Okay, so now we have the other videos. We have this. We have these other values. We're saving the YouTube video. I also want to write this to DynamoDB. Now, what I could do is I could write another Lambda function. So I could have this Lambda function return all of this information and then have like another Lambda function that writes this to DynamoDB. You might even be able to write DynamoDB directly from state machine. I'm just going to put in here a call to call DynamoDB. But before we can call DynamoDB, we have to actually define the table. And we can define the table. I could go into the AWS console and define the table there. Or what's better is, because I'm using CloudFormation, is I can define the table in CloudFormation or SAM. I'm using the SAM framework again. So let's see if there, I believe SAM has syntax. Okay, I just need to, AWS SAM, I always know how to get to the documentation by like searching one of these types. It should get me to the documentation where all the resources are explained directly. So SAM, again, sits on top of CloudFormation. I can specify this directly in CloudFormation, but I'm wondering if SAM has, it has a kind of abstraction layer to make, so you can write SAM syntax, which gets compiled into CloudFormation syntax. And this is a little bit easier to write with, I think. Okay, so this is exactly what we're looking for. So let's create a resource for this. We'll call this video metadata table. And do an indent there. So what are required here? Primary key is required. And here's an example. Table name is not required. And this is important. I actually don't, I never like to specify table names. And the reason why, here, let me put this back in. If I specify a table name, like I call it video metadata table, and deploy this, it'll go create a video metadata table. Now let's say I had another YouTube channel that I wanted to be listening to, so I wanted to redeploy this infrastructure into the same account, but just like redeploy the infrastructure. Well, I'd have a collision with the naming of this table. And so I don't like to specify the names. If I leave off the name, what usually happens is CloudFormation will name the table like something based off the resource name, and then it'll like add in some random characters to ensure that it's unique. Tags are not also required, so I'm going to remove that. SSE, server-side encryption, it's just public metadata, so I'm going to get rid of it. Provision throughput is not required. We're going to have very little throughput. I'm not even going to worry about that. But primary key object, I feel like this is what we want to specify. So here, so again, DynamoDB is a lightning fast like key value pair lookup database. So here you can specify an ID and like I think it's, what is it called? Like a sort key. I think of it as partition key and sort key because I've used Cassandra for a number of years, and that's kind of the same principles. But here I'm going to call it a primary key. I only need one, and I'm not going to call it my primary key. I'm going to call it video ID. That's what we called it here, right? Or just ID, in fact. Okay. So now I have my database table defined, and now I can start actually writing data to this table. Because when I redeploy this now, CloudFormation is going to say, oh, I have a new resource. Let me go and create this resource. So now here, now I can actually start writing to that. So one of the things I need to pass in the name of this table. So let me look at, let me go back to the table definition. So the return value, logical intrinsic resource name of the underlying DB database table. So if I do this, table name, ref, this guy, it should pass as an environment variable to my Lambda function this specific table name. So now what I can also do is I also need permissions to be able to write to this table. So SAM, AWS, permission, write DynamoDB. Let's see if there's a great example of this so I don't have to go and determine this. Or is there even policies that we can just use? DynamoDB write policy. Okay. This looks good. Is there a version? Dang, it's not a YAML version. Okay, that's fine. So let's add to the permissions of our Lambda function another statement set. What, I don't know what it's called. DynamoDB write effect allow action. This is where we only probably need these two. I'll add batch write because why not? And then the resource is going to be, so the resource is always like the ARN, like kind of the address of the resource. And so, wow, it's very verbose syntax. Needs these two resources. So table name, so instead of table name, we're gonna put in the resource reference here. And then I wanna make sure I get the rest of those right. and account ID. Region and account ID. I always put AWS here. I suppose there could be different partitions, but that's what I always use. Okay, and then I'm going to also specify all the indexes for that table. Okay, so this is table name / index asterisk. Okay. So this should be permissions now. This DynamoDB can write, or this Lambda can write to DynamoDB. So now we actually need to get that DynamoDB table. So let's open up our Node.js DynamoDB developer guide and load sample data. Is what I was looking for. Dot client. Okay, so first you create your client from the AWS SDK. So I have a dot client. Now here, let me do this. Try. Here what we're going to do is we're going to create our parameters and then put those in. If that makes sense. So the table name is actually from our environment variable. Process.env. I think it's table name. I never trust myself. So I'm actually just going to call this table name. Table name. And then item. Here, we need to specify all the parameters. And one of those parameters needs to be the primary key. So ID is like the important one, so we'll get that. ID, and then now we pass in the rest of them. So we'll do name, publish date, description, the nice thing is, for defining the schema of this table, we only have to define the schema of like the indexes and the primary keys and so on. We don't actually have to define the schema of all the other columns. And so we can just load whatever values we want, and DynamoDB will just load those as columns. Okay, so length seconds, description, IDs are primary key, publish date, and name. Okay, so now put params, and then actually I want to do this as a promise. So how do you do that? Is it this? Is this the correct format? Node.js, DynamoDB promise. Dot client, but I'm pretty sure this is the right way of doing it. Cool. Okay, that's what we want. Okay, so now instead of my promise there, what I'm going to do is, I'm just going to put this, actually, let's put this, let's not do it like that, because now we're using a promise chain. So we're going to do return this promise, but then we will put this whole thing here. Move this up here. Okay, so what am I doing? I am calling getInfo, awaiting that. I could await the response to this, but I kind of want to capture, if there's an error, I kind of want to capture it as one big catch block. So this, let's see, that's on column 5. This should be on column 5. And then let's do console.error. Even better. And then return. Let's return something so that the state machine will now fail because it won't get the expected result. Okay, so if this runs, it should get it the info. It should then write it to DynamoDB, and then it should move on. So now we're saving this metadata information, and I think we should deploy this code and see what happens. Okay, so I have one command here that will build all my functions. That's perfect. Look how fast that failed. Mapping values are not allowed here. What did I mess up? Was that what's wrong? Name, type. What did I mess up? That's what I messed up. Okay, there we go. Okay, so what it's going to do is it's going to go into each of the folders of all the different Lambda functions defined by these resources in the code URI, and so on. Hold on. I'm getting pinged by my boss. I just want to make sure I'm not in trouble. I have like 8 Slack notifications. Cool. Okay. So it's going into each one of these. It's using Docker. It's using a Docker image so that when it downloads, when it starts to build the Lambda functions, it does it in a Docker environment that simulates the Lambda environment. So it'll get all the right dependencies, packages up the zip file correctly. So when it uploads that zip file to AWS, everything's good to go and run. It's not dependent upon like if I'm using a Mac or Windows or Unix or whatever. So it's building all those, it's getting all the dependencies, it's running npm for package management for my node function, it's running pip for my Python functions, downloading it all, and so on. So we have that. So while it's doing this, let's actually go into one of these. There we go. Is my Lucid chart. Because what I want to do is add the DynamoDB table to my chart. I have a bearded dragon over there, and he's finally eating the kale that I've been trying to force feed him. His name's Steve. Okay. So I'm just going to throw DynamoDB over here as well. The hard part with these diagrams is like I'm using Lambda to call these other services, but I don't necessarily want to put like Lambdas like absolutely everywhere. So this may just exist out here without an arrow just to kind of show that metadata is going there. Actually, no, I'll do this. I'll draw an arrow from... I'll do this. Metadata. Okay. This isn't exactly accurate, but right. But like metadata is coming from YouTube into DynamoDB. And we're using a Lambda function to do that. But if I wrote all the Lambda functions, there would be like a Lambda function like everywhere. So maybe I'll redo this architecture diagram like when I'm like finally complete and it actually makes more sense. Until then, there's that. And so we have all this done. I've actually figured this part out too. So there is, which we're going to get to maybe Monday. what I need to do, I found a mechanism where Google will post to me when new YouTube videos are uploaded and ready to go. And so what it's going to post to is actually API Gateway. So I know now that this sits here and kind of looks like this. Okay, so this trigger, and this trigger is actually not, oh, don't do that. I am having a hard time selecting that. Okay. This is going to come from Hubbub, which is a new, I haven't ever seen this service before, but it's a really cool, like, so basically it's a Google hosted thing. You give it the Atom feed that you want from the YouTube URL, from the YouTube channel, and then you give it the webhook that you want it to call, and it'll pass through. I was hoping we'd get to this today, but we had to do all this work with YouTube, so that's where we're at. And then, so behind API Gateway, there will be a Lambda function that will verify that the incoming request is coming from where we want it to come from. And then what it'll do is it will pull out the YouTube video URL, and it will trigger our state machine. And then everything gets passed off to the state machine from there. Okay, so here is what it found. So it's creating a DynamoDB table that we just defined, and then updating now the rest of these. Okay. Now what I also want to do, so that's deploying out there. Let's actually make, this is actually fairly quick, so let's sit on it and make sure that it deploys correctly. So a deployment failure could happen if, like, let's say I had a typo in the CloudFormation template. This happens a lot when I'm actually updating state machines, because in order from the way that I define the state machines in CloudFormation is by this giant string of JSON that gets packaged up into a big YAML file. So this is very error prone. I usually forget like a double quote or a comma, and the whole thing blows up. And it blows up as it's deploying because CloudFormation says, I don't know what to do with this. Okay, so now it said create complete. So we can, on the table, not the whole entire infrastructure, but that'll be finished in a second. Okay, so now if I go up my CloudFormation stack, it says update in progress. I should actually make sure it actually completes. Now it's updating the YouTube. Okay, that's been updated. So now if I refresh my resources on the CloudFormation stack, there should be a DynamoDB table with the name video metadata. Look at that, there it is. So if I click on this, it'll take me to the DynamoDB console where I can view this. And there it is, there's my table. It has an ID column. Okay, so now if I go back over to my Lambda function, if I refresh this page, it should like reset back to the new code because I deployed over it from my local machine using SAM. And here it gives me that warning. Great, here's my new code. So again, what I'm doing is I'm passing in one YouTube video link. So let's test this. The next step is I'm going to put this into the state machine and run it there, but I want to make sure this logic is sound before I modify the state machine, then like kick off the entire state machine. I want to make sure that this is working. I got the permissions set up correctly, that it's able to put data into the right table and all of that. So let's run this and make sure this is working. And it should actually by now be in the table. So if I go back over to DynamoDB and click on Explore Items, look at this. I now have my metadata. Yes, it's worked perfectly. This is awesome. The one thing I'll probably change is this is my file name safe name. And I'm not going to deploy this just right now, but I do want to change this so here what I'm doing, I'm getting the title, but then I'm doing this string replace to give me a file name that's actually safe. So let me do this. me separate out these two variables. So now I have the title, which is directly, and we'll actually call it title when we put it in the DynamoDB table. I like to keep it consistent with like the source API. So this will get overwritten. Actually, we might as well keep name in there too. But maybe the name, maybe we should actually be the key. So now we know exactly where in S3 it is. Oops. Or maybe we do both. Perfect. Okay. And I don't have to do anything to redefine the table because my index, my primary key is still the same. It's just ID. So that's all we have to do. Okay, so this is working. Hopefully this failed. You know why it failed? I know exactly why it failed. It failed for the exact same reason it did before. So before, I manually updated the memory from 128 to 512. But when I redeployed from my local machine, it redeployed the infrastructure that I defined, which by default is 128. And it's not even specified. Just when you deploy a Lambda function, the default is 128. So I actually had to specify the memory here to be increased. Just so I'm not guessing off the top of my head, if I go into the SAM documentation and go to function, it should be just memory size. I see I would have guessed memory. And it's a type integer. So here I'm going to do is I'm going to say 512. So now when I redeploy this whole format stack, it will update the memory size, and it'll always be 512. Okay, but I want to do one quick thing first. I want to add this to my state machine. So my state machine is defined down here. And actually, I haven't showed this yet in this today. Where is my state machine here? So here it is. Last time it ran successfully, which is awesome. So here's my state machine. It starts by doing a YouTube conversion with media convert, the output file, then we wait on that to finish, and then it does transcribe start and so on. But the very first, I need to change this, so the first step is actually to go download the video. So what we're going to do is we're going to change this. We're going to add a new state for YouTube download. It's going to be a task type. I'll just copy all this. Task is type, or type is task. The resource, I need to update this. And then the next step is actually YouTube convert start. And then my whole state machine, I'm going to say the start is now YouTube download. So now it starts here and then goes on. So resource, this is actually, it needs to be like the full ARN of my Lambda function. And the way I do this, I have like a very common way I do this. I come down and I say it's ARN, but I'm doing a whole string replacement substitution on this entire string. So I come down here and I say the substitution values are this is equal to okay. So now this value, which is the ARN of my Lambda function, will get put into this string value when it's doing substitutions. And then the other thing I need to do is come down and make sure that my state machine has permission to invoke that Lambda function. And actually, I want to put this at the top because it is actually the first function. Oops. I like to keep things clean like that. Okay, so now my state machine should be updated to add this new step in, which is going to be the YouTube download. And I think this will be the actual start of my state machine. So the other steps, let me actually build this while I'm talking. I'm going to go through and rebuild everything. So the way this, I'm defining it here in JSON, but it actually builds out this. And you can actually come over into, here's the exact same JSON. But I think I always like to talk about this because I think it's really, really important and kind of a really good best practice. So most of these, like the convert, so converting the video can take about 10 to 15 minutes using Media Convert. It's an hour-long video. It's converting from one media type to another media type. And then transcribe start, it goes through the entire video and pulls out all the text. That can also take 10 to 15 minutes. So the pattern that I use for this is this like start and wait pattern. So here I'm saying start the process of converting the video, and then that calls a Lambda function that all it does is call an API to say start the process. And that Lambda function gets done in a few milliseconds, and so the cost is like almost negligible. And then what I do is I have state machine here wait for 30 seconds. So this is not a Lambda function, this wait step. It's actually a built-in state that just says just wait 30 seconds. And then when it's done waiting, call this next step, which is a Lambda function, which will just check on the status. So it just calls an API, grabs the status, and returns it back. Again, executes in a few milliseconds, extremely cheap to work with. And then I have a step here that says, what was the status of that? The status was complete. Now go on to the next step in the state machine. If it was error, then go to the error path. If it was anything else, like in progress or not started or anything like that, go back to the wait step. So here, like this whole process can wait for 30 minutes, an hour, a couple days. And I'm charged like almost nothing because I'm not actually letting Lambda execute for 15 minutes waiting on the response. The YouTube convert doesn't follow that pattern because we're streaming live. There's no asynchronous process, and we just have to wait for it to finish. So this Lambda function is going to be exponentially more costly than this Lambda function, but it's still going to be very, very cheap to run because we're only running this like once a week. So not a big deal. Okay. Now it's initializing the deployment. So it's creating a change set based upon the state that I defined plus the state that's the reality up in the cloud, saying here's the change set. It's going to say like, here are the changes. Do you want to deploy these changes? I'm going to hit yes. That's what I modified. And then now it's deploying those changes. So it says here it's going to modify Lambda function. It has to basically delete and recreate the Lambda function because I changed like the memory size of that. I think that's what that means. So there's some resources that it can change in place, and some resources it has to like delete and change. Maybe this is one where we can just do it in line. It's finished the Lambda function. So let's go over to the Lambda function here. And if I refresh the browser, this 128 should change to 512. Perfect. Okay, so this should run now. My step function also seemed to have deployed. So now if I come into my state machine, look at the definition, there should be a new YouTube download start, which is awesome. So I want to kick this off. And if I say start execution, it gives me like this default whatever. If I go to a previous execution of this state machine, and I say new execution, it'll give me what I passed in there. But this is actually not the entry data needed for the state machine anymore. This was the entry data needed when Media Convert was the first step because it needed to know where the unprocessed video file was. Now our YouTube download is going to return this value. So now what we need to do is pass in what the YouTube download is expecting. And YouTube download is expecting, I actually have it as in my Lambda. So if I go over to code and I say, yes, I know, and say configure test event, this is now what is expected, just the URL. Come over here. So now I'm going to say start an execution, and this is the input. So I'll start this execution off, and the first step is it should go to YouTube download, and it should download it. And so now again, so we're done with the beginning of the state machine. This is forever going to be the beginning of the state machine. It's always going to now take in this value. And where's it going to get this value? Again, it is going to get this value from our YouTube subscription. So we're going to set up a subscription. We'll call API Gateway. API Gateway is going to pass in, it's like an atom feed of just one item. API Gateway is going to pass that to a Lambda function. That Lambda function is going to parse out this URL, and then it's going to say, start a new execution of state machine. Here's the input, the video URL, and off it goes. So then the nice thing is this API Gateway Lambda can resolve itself in a few milliseconds. All it's doing is calling one API to say, start this asynchronous process, and then it can return and tell pub sub hub bub that we're done, we're good, we got the message, off you go. And we can also log it to make sure that we have that. So let's come over here. It did download. So if I go over to my S3 bucket, it should re-download it. Everything should be the same, except this should be like 10:15 or 10:16. Boom. Awesome. Okay, and then now we're not going to be able to finish it because this will probably take like a half hour. But it failed. Why did it fail? Error. Okay, let's go into media convert. I wonder, I have an idea of what could be wrong. And we can also go to the CloudWatch logs of this. So we should be able to get this error directly from media convert, not found in input container. Interesting. I'm going to download this video. So I'm not completely surprised about this because last time, so when we configured media convert, we gave it a job template. And this job template I manually created a few months ago. And I manually downloaded a YouTube video and used this job template to convert it over. So there's a very good chance that when I manually downloaded the YouTube video, I got it in a completely different format than what I just did now. And so what I'm wondering is if my formats are not right. So I just did this one, this format, has audio false. Look at that. So we want one that has audio true would be, that's why I wanted to download, I'm still downloading that video file. Okay, let's go back to the documentation of this thing. This might be useful if like I read stuff all the way. Interesting. Let me just do a search of has audio true. So this, what's the version, or what's the video width? Has video false. So that's just the audio feed. Okay, this is true, 720p. I wonder if this is true, 640, 360p. True 720p. I wonder if this is going to be the best we can get, which would be a shame. But it may be big enough for what I need. Still downloading. But actually, so I'm going to go into my Lambda function. Here, just downloaded. You can't hear it, neither can I. You wouldn't be able to hear it, but I definitely can not hear anything. So here's what I'm going to do. I'm going to go to my Lambda function. I'll look this up. I gotta jump off here really soon. I'm going to switch over to this iTag of 22, 722 or 720p. I'm going to paste that in here, deploy it locally. Let me also update this code as well. So my local is now in sync. And let's kick off another step function and see if we can quickly see if this will work. And I'm also curious to see how big that file is. So I also want to download this other one that I've been working with that I downloaded a long time ago. It's 1 gigabyte. I want to see what the metadata is for this and how it compares to that the other one, like what the resolution is. It seems odd to me. There's something not sitting right with this, but that's okay. I don't want to like process the audio and the video differently. I think that's just asking for trouble. I would love to have higher quality than 720p. I think on like these devices, I can get much higher resolution, but for some reason, these formats aren't coming back as allowing me to get the audio and video together, that's weird. So I'll need to look into that. That's really weird. So I'm downloading that video, running this step function. Let me commit all this in. I think I'm done making code changes for today. Let's look at the DynamoDB table, and hopefully we have a few more properties here. Boom. So now I know the key, I know the name, and I have the title. This is looking good. This seems to be doing better. It seems to have like found the audio track. Let me see what the CloudWatch logs say. Okay, it seems to be chunking away. That's great. Okay, so I'll need to do a little bit of work to figure out what's going on. Again, now I'm working with what seems to be working is iTag of 22 to this YouTube API. iTag 22 translates over to a 720p video format. I would like to have better video format than that, so maybe there's something I'm missing in the APIs. I will take a look at that, but I gotta drop now. I got another meeting I gotta get ready for. But thanks for following me along. We made some good progress today, I think. I wanted to get to the trigger, and we're gonna get there. Could not be open. Can't even open it. Download the one that we've been mucking around with. I can't even open it. Okay, so we made a lot of progress. We'll get to the trigger next time. So that'll be on Monday. And we'll go from there. But thanks for following along. I have no idea how long this is going to take to do this. At some point, we get to Alexa Skill and the Alexa front end and start building out that and using APL docs to build out like a media player so we can actually play the videos. And actually, my goal is to be able to play it on these devices. So follow along for that, and we'll get there eventually. All right. With that, I'll say thank you.